Hi everyone, I'm RUJUN. It's very glad to be here today. The topic of this presentation is this. And I will cover this presentation in these four aspects, and the remaining I want to focus was the whole realization procedure of my developed method. Nowadays, the fatigue life of the many machinery components are exist 1 billion cycles, and sorry, a little bit nervous. This is my first time. And which are significantly larger than the fatigue life range, which we all used with the traditional fatigue test. And in the very early stage of very high cycle fatigue, an important area called finer granular area will be occurred around the critical defects in materials. And as typical future region, FGA provides an insight into the evolution of the defects and the cracks from the main idea of the famous Murakami formulation. We can get then to the stress of the several each stage of this very high cycle fatigue can be characterized by the size of the filter region, in the fracture surface. So how to measure FGA has become an important and practical, more important and practical. As a method, a deep learning based method was proposed in Python language throughout the whole realization procedure. And there are 4 main measures I put here today, and the last one was the practical application measure that we can define it with our suppose. When it comes to deep learning method, datasets are the basis of the analysis. This flowchart contains all the dataset preparation steps. And as for it's necessary to create a set of labels to indicate that what kind of element is can indicate what kind of element is the FGA on the fracture surface. And so an automatic and annotation method with developed threshold segmentation algorithm was used in this work, and the offline data augmentation and the data format standardization are also crucial for this step. And for the key step is the future segmentation procedure with which is a classical semantic segmentation neural network called UNet I used in this. And on the one hand, both the loss function and the MROU tendency are used to evaluate this training process, this neural network training process. And until they are all they are all remaining relatively stable, and that indicates that the model has learned the essential feature and the segmentation patterns from this training data set. And on the other hand, such as this precision, pixel accuracy recall, and the MROU are all used to assessing the final segmentation result. And this shows that they are always overall with the great accuracy of this trained model. And for the image predictor program, we can import we can choose to import a single images or a bunch of single image or a bunch of images. And according to the magnification table we can get the actual FGA size on any images. Yeah. And in this step, 32 set of different fractal surfaces with totaling 352 images was used to predict the discrepancy of the FGA size between the annotation and the predicted results were really small, and the errors between the predicted and the average results of each specimen surfaces were negligible, I think, yeah. Anyway, this all highlights the developed method could be a better way to realize the segmentation and the qualification of the FGA. And that's the practical application of the safe calculation I was mentioned in the introduction, part. As shown in the equation, FGA size and the stress are the two key parameters for this safe threshold. And the former one can be get use our developed method, and this one can be get from the analytical solutions. So based on the given images, specimen types, and the materials parameters, and the judge the correct location, and then the safe can be output in the end. And here is the illustrative example for 3 types of common used specimen in very high cycle fatigue. The stress distribution along specimen century axis can be exported. Yeah. And combine it with the FGA size we got from the actual OM images. We can, yeah, the safe threshold distribution for the different types of specimen can be obtained ultimately. Now in conclusion, with Python language throughout the whole realization procedure, this method shows good accuracy and efficiency in the fractal surface image analysis, and it significantly reduces the cost and the time of the original images taken, and demonstrates clearly practical significance in very high cycle fatigue research. And it is also can use in deeper extensions and applications to make more practical application with users purpose. Yeah. Okay. The study has provided valuable insights while my research has come to an end. Yeah, thank you very much for your time and attention.